In this presentation, we're going to look at the exponential distribution. And in fact, what we're going to look at is a pair of exponential distributions, x and y. And x and y are independent and identically distributed. This is a little phrase you should get the hang of: independent and identically distributed. Now, so they're independent and identically distributed IID random variables with an exponential distribution with mean 0.5. If the mean is 0.5, my pen is slipping there, that means lambda, the rate parameter, is 2. The rate parameter is 1 over the mean, 1 over mu. Okay, so what we're going to do here is define W, which is the minimum of x and y, the pairwise minimum, and obtain the cumulative distribution of function of W. And also what we're going to do is calculate the mean of W. So given that x and y are IID from the exponential distribution with mean 1/2, that means we could sort of say the following. Okay, we just could sort of specify them out like that. Okay, they're both at the same distribution. Anyway, so just as a quick remark, and this works for both cases, this is just the definitions or the theories related to the exponential distribution. The cumulative distribution function, which is probability of x less than or equal to t, can be written as follows. 1 minus e to the minus 2t, okay, for t greater than 0. That's 1 minus e to the minus lambda t. That's what you should see in your tables, okay? And that means the inverse of that, the complement of that, I should say the complement of that is e to the minus 2t, e to the minus 2t, okay? So that's the that here is the complement of that here, which is to say that here is the complement of that there, okay? And we can say the same for y. The probability of y being greater than t is equal to the exponential of minus 2t. Now, our minimum is the minimum of x and y. We define that as w, and what we have to do is come up with the cumulative distribution of that. Okay, so f of w, capital F of wt, is the probability of w less than or equal to t. Okay, and we're going to express that in terms of its complement, which is to say the probability of 1 minus the minimum being of x and y being greater than t. Now, this is the trick of this question here. This part here, minimum of x and y being greater than t. That means that x is greater than t and y is greater than t. So that's why I'm able to take this step here. Okay, so I can re-express that as 1 minus the probability of x greater than t and the probability of y greater than t. Okay, and those are two independent events. Okay, so what I have now is 1 minus the probability of x greater than t times the probability of y greater than t. I'm stuttering here a bit. So that is 1 minus e to the minus 2t times e to the minus 2t. Just multiply them out and we get 1 minus e to the minus 4t. Okay, so that means that the rate parameter of that is 4, and that's an exponential distribution. So w is exponentially distributed with a rate parameter of 4. Okay, my pen is slipping again. So let's do that. And that means pretty clearly you can tell that the mean there is going to be 1/4, 1 over 4, because that is 1 over lambda. Okay, so mean of w is going to be 1 over 4. Okay, that's it. We'll leave it there.